Yeah, good afternoon. So this is the DT-based delivery on economic dispatch. So here there are three thermal power plants. For each thermal power plants, they are giving the fuel constraint equations. This is for unit 1 fuel cost equation and unit 2 fuel cost equation and unit 3 fuel cost equation. So like 0.0045 Pg1 square plus 5.2 Pg1 plus 580. So like that for all three units, all the three units are belongs to thermal power plant. So they are giving the fuel cost equation for all three units. Okay. And additionally, they are giving the total load of 925 megawatt. So all the three units combinedly, it should meet out the demand. The required demand is 925 megawatt. So all three units combinedly operate and it should meet out the load demand of 925 megawatt. And for each unit, they are giving the constraints, operating limits. So for unit 1, unit 2 and unit 3. So this is nothing but a minimum value and this is nothing but a maximum value. This is nothing but an operating limit. So the unit 1, it should operate between 250 megawatt to 450 megawatt. So it should not operate below the 250. Also, it should not operate above 450 megawatt. So it should be operate within a limit. Okay. So here we have to determine the optimal dispatch. Here we have to determine optimal dispatch and also we have to calculate the total cost to meet out the demand of 925 megawatt. Okay, so here just they are asking the optimal dispatch. So no need to go for unit commitment. Simply we can go with economic dispatch problem. Coordination of economic dispatch. So here there is no losses given. So here we have to consider the losses are neglected. So without losses. So that we have to proceed the problem based on the economic dispatch without transmission losses. Okay. So here, so what is the step-by-step procedure to calculate the optimal cost and optimal dispatch? So what is the step number 1?
In step 1, we want to assume the initial value for lambda. To calculate the lambda by the formula, lambda is equal to PD plus summation of BI divided by 2AI whole divided by 1 divided by 2AI.
2AI, very good. So if the problem is given, the first step we have to determine the lambda by using the formula. By using the formula, we have to determine the lambda. That is nothing but step number 1. And what is step number 2?
The step number 2 is we have to compute the Pg1 corresponding to the lambda, either the equation. The equation is Pgi is equal to lambda minus Bi divided by 2ai, where the I represents the unit number.
Okay. So here, in step number 2, we have to determine the Pgi. The I indicate unit number. If you are given you 3 number of unit, so here we have to determine Pg1, Pg2, Pg3. That means the power generation from all 3 units. What is the power generation from all 3 units? We have to calculate Pg1, Pg2, Pg3 by using the formula lambda minus Bi divided by 2ai. So here the Bi and ai, which is taken from the fuel cost equation, So here the this is nothing but a coefficient, this is B coefficient, and this is nothing but C. So like that we can able to get the values from the fuel cost equation for ai, Bi, and Ci. Okay. So okay. And what is the step number 3?
Step number 3. The step number 3 is we want to compute the PGI satisfy operating limits. If you attain the limit value and the minimum value, it will obtain the solution. Otherwise, go to next step.
So in step number 3, so already we have determined the Pg1, Pg2, Pg3. Now the value of Pg1, Pg2, Pg3, it should be compared with the operating limit. If all the value of Pg1, Pg2, Pg3, if it is satisfactory, if it is within a limit, then we can move into the next step. Okay. So in third step, so we have to check the operating limit. We have to check the given operating limit. If everything is okay, it is operating within a limit, then we can move into the next step. Okay. So what is the step number 4?
Step number 4, if the PGI violates the operating limit means you have to fix the generation at the respective limit. So if PGI value is less than the PGI minimum value, we have to fix the PGI minimum value as the default value of the PGI.
So okay. So if it is not, in previous step, if it is not satisfied, then we have to go for the next step. That is next step. So again, we are checking with the limit. Suppose if the determined value of PG1 or PG2 or PG3 is below the minimum value, the given minimum value, we have to set the minimum value. So for example, if the unit 1, the determined value of unit 1, that is PG1, is 200 megawatt. But the 200 megawatt, which is less than the minimum value, So here we have to set or fix the value of PG1 is 250. The minimum value can be set as PG1. So then we have to go for next step. Okay, next step. What is the next step?
If PGI violates the operating limit, then fix the generation at the specific limit. For example, if the calculated PGI is greater than the given PGI maximum value, then we have to consider that the PGI is equals to PGI maximum.
PGI maximum. Suppose the calculated value of PG1 is 500 megawatt, but what is the maximum limit? The maximum limit is 450, but the calculated value is 500 megawatt. So the calculated value of PG1, which is greater than the maximum value of PG1. So during that time, we have to set or we have to fix PG1 is equal to maximum value of PG1. Okay. So what is the next step?
We need to compute the power generated, which means how many units are there. We need to determine that, and for every unit we need to calculate the power generated.
Power generation. Okay. Next.
Next, we have to check the total power generation is equal to total power demand or not.
Okay. So finally, so we are calculated the value of PG1 plus PG2 plus PG3. So the summation of all the 3 units, which is you should meet out the total demand or not. So we have to check. Once it is satisfied, then we have to go for the next step. So what is the next step?
And my step is PCA is greater than and power demand we have determined. We want to analyze the increment operation and go to next step.
Okay. So here we have to check with the power demand whether it's less than or greater than. So based on, we have to go for the next step. So in the next step,
Conclusion. First, find all PGI values and check the minimum and maximum maximum operating limits of each unit, and substituted in fuel 1 and fuel 2, fuel 3 cost, and then find the total fuel cost. This method is called optimum economic cost.
okay, right. So in the summarize, so here there will be a fuel cost function given, total demand given, and operating limit will be there. So here we have to calculate the lambda, then we have to determine the PG1, PG2, PG3, and we have to check the PG1 value, PG2 value, PG3 value with respect to the operating limit, whether it's should or whether it's within a limit or not. If it is within a limit, then we can move into the next step. So otherwise, we have to set the minimum value or maximum value. Okay. So next, so the total power generation, whether it's meet out the total demand or not, we have to check. Everything is satisfied, then the calculated value or the determined value of PG1, PG2, PG3 can be substituted in the fuel cost equation for unit 1, 2, and 3, so that we can get the total optimal cost. We can get the total optimal cost. So this is the procedure to solve the economic dispatch without transmission losses. Any doubts? No, thank you.